Hello, class. This is the second part of linear modeling section 4.1. And before we do some more models, I just want to give you one more, starting off easy, hopefully. This idea that when we were talking about functions that are increasing, decreasing, or constant. We talked about that quite a bit again in chapter 3. And the good news is, as we alluded to in the last lecture, is that whatever the slope is will dictate if it's linear, if it's increasing, decreasing, or constant. And if the slope is positive, it's increasing. Slope is negative, it's decreasing. And the slope is 0, it's a constant. So usually it's good to write this down. So let me do that. So when the slope is greater than 0, it's always increasing. And since the slope never changes, it only can go one way, right? If the slope is less than 0, it's always decreasing. And if the slope equals 0, that's a constant. And that would be a horizontal line. So just a couple quick examples, and then we'll, in my opinion, we get to the real fun stuff. And so let's take a look at, say, these 4 equations. So equation A has a slope of positive 5, so that would be increasing, excuse me. B has a slope of minus 2, and so that would be decreasing. C has a slope of 3/4, and so that would be increasing slowly, but it would be increasing. And you could see D is an equation of a horizontal line, y equals 7, and it would be constant. And so you would graph that, and you would just have a horizontal line at 7. Okay, so let's build some models. And so we're going to focus on 2 different ones. They're both in the business. The first one's an accounting idea where we're going to be doing depreciation. And the second one is going to be a business, which I really think it's important to understand the cost, the revenue, and profit if you ever wanted to start your own business. So probably sick of seeing that, but there we go. Y or f of x equals mx plus b. So here is our problem. And this is called straight line depreciation. And when I used to own a company called Let Us Cater, we built a website. Original website was about $50,000. And we did straight line depreciation over 7 years as well. That was back in 2007, I think. And so every year we got to write off a certain portion of that website for 7 years. And so what this says is a company is buying a fleet of vehicles, and each vehicle costs $31,500. And the straight line depreciation is this idea that every year you could depreciate a certain portion of a big investment. And so this idea of generating an equation is nice because depreciation is a nice straight line. And so to calculate, I paused there for a second, I had to cough. So to calculate the equation, we need 2 things, right? We need the slope, and then we need the y-intercept, right? That would be our b, and this would be our m. So what would be our slope? Well, the way it works is that every year you could depreciate a certain portion of the vehicle. And depending on the way that depreciation is set up per years, will give you the slope. In this case, we have 7 years. So what you do is you take the value of the vehicle and you divide it by 7, and you see here you would get $4,500 per year. So that's our slope. But is it negative or is it positive? Well, what ends up happening with depreciation, every time you claim depreciation on your books, the value of that asset goes down by that amount. So this would be a negative because it's going to decrease the value. And so the way it works is that this M here is going to be negative 4,500. And so when you set that up, it would be minus 4,500. And if we call X is years, right, again, time, and then Y would be the value of the asset, in this case, the car. And so, or truck. So what is our B value? Well, what's the point we have? Well, what do we have? We know that we bought each vehicle at $31,000, So we know at time t equals 0, $31,500. So what is that? Well, this is our y-intercept. So that one's kind of nice. So the y-intercept in the depreciation is always the initial value of the asset that you actually are buying. And so, like I said, my website was 50,000, so it would have been that. And so this vehicle here is 31,500. So what ends up happening is every year you get to take off another $4,500 right off your profit line, which is nice. So you don't have to pay taxes on it. And so this is what's called book value, and it's accounting value. It's not the actual value. If you could sell the car or the vehicle for more, that's okay. But this is more of an accounting tax thing that we have to deal with. So what would be the book value, say, after 3 years? Well, you would just plug 3 in for X, and you would see what it would be. So if you did this calculation, that would be 18,000 there, minus 18,000. No, plus 18,000, sorry. So just pull out my calculator here. So 4,500 times 3 is 13,500. And then if you add, you would get 18,000. So the book value of each vehicle after 3 years would be $18,000. So for those accounting people in the room, that would be something that you would end up doing. I know my accountant that used to do it for me all the time. And so what ends up happening after 7 years? Well, the book value would be, if you plug in, it better be 0 or we did the equation wrong, right? If you plug that in and you got out your calculator, you would get 4,007 times, and you would see that would be minus 31.5. And so your book value at the end would be 0. So one thing I do want to show you is it's useful to graph these things. So why don't we see what it looks like on Desmos? And I'm going to use Desmos quite a bit to illustrate some of these graphs. And so this would be y equals minus 4,500 plus 31,500. Forgot my variable. Better put an X there. And so you could see in Desmos that sometimes the scaling gets a little weird. And so sometimes it's good to go up to this graphing setting and set your own scale with regard to that. So what we need to do on the x-axis, right, we want say from 0 to 10 years on our x-axis, and the y-axis, let's just say from 0 to 50,000. And so you could see that's what it looks like now. And so you could see that here's our y-intercept at 0.315. So that's when you bought the vehicle. And every year it's depreciating. And you see that when you get to year 7, that it's worth 0. So this part of the graph down here and this part of the graph up there doesn't make any physical sense with regards to that. But math-wise, you can see that it goes on in both directions. So you know what I'm going to do here is stop this one and then do the last problem, because the last problem's going to take probably 10 minutes, and I don't want these videos to get too long.